I'm a biologist here at Macquarie Uni. My field of expertise is marine ecology. So basically what I'm interested in determining is the factors that determine where plants and animals live in the environment, and I guess how we as humans are modifying those and how we can minimise our footprint as humans on the marine environment. And so some of my work I do here at Macquarie, and I'm also involved in something called the Sydney Institute of Marine Sciences, which is a consortium of about 6 universities in Sydney, where we actually have something called the World Harbour Program, where we're really interested in understanding, I guess, the impacts of development in coastal environments across the world, and how we can maintain ecological values in these highly developed systems. And so, as you probably know, for many years we've been modifying the land. We've been clearing the land for agriculture, we've been clearing the land to build our towns and cities. But what you might not realise is that in recent years actually there has been increasing development in our waterways as well. And so on this first slide here you can see a picture of Sydney Harbour, and you can see that, you know, as well as all of the city in the background, there's actually considerable development on the waterway as well. So here you can see some marinas and the little inset on the side. They're busy building some wharves as well. So if we look around the world, there are many types of development that are occurring in the marine environment. And so first of all, I guess we have development that is based around protecting our shorelines from storm surges, coastal flooding, that kind of thing. And I think some of you might have just listened to a talk on climate change, so I'm not sure what was covered there, but one of the issues in the coastal environment is rising sea levels, which are actually causing risk of inundation of a lot of coastal property and infrastructure. So that's one type of development. We have the rise of aquaculture. So aquaculture is quite an efficient method of producing protein, and I guess increasingly is going to be a major source of protein around the world. So this is actually down in Tasmania and some of the salmon farms down there. We've got recreational activities that occur in our waterways, so boating, and so I guess associated with boating is all kinds of infrastructure. So it might be marinas, it might be boat ramps, it might be mooring buoys where people can moor their boat and stop. We have things like artificial reefs, and so, you know, I guess in a number of places we're actually building these reefs as recreational fishing havens to support some of our recreational activities. I guess along the west coast of Australia in particular, we have a lot of drilling for oil and gas offshore, and there are other parts of the world such as the Gulf of Mexico in the USA where we have very large concentrations of these kinds of structures. And some of you might remember the Deepwater Horizon oil spill a few years back when things went horribly wrong with one of these structures, and I guess all of the impacts that caused on the marine environment. We have things like roads that might pass over waterways, and so obviously we need development in our waterways to help support that. So this is just the underside of a bridge and the pilings and the types of infrastructure we see there. And then more and more what we're also seeing, perhaps not in Australia yet, but certainly in other parts of the world, is energy generation that is occurring in the marine environment. And so things like offshore wind farms, this one here I think is power generation based on harnessing energy from waves. People are also harnessing energy from tides as well. And so all of these types of activities actually introduce new structures into the marine environment that wouldn't have been there before. So just to give you an indication at the rate of growth of development in the coastal environment. So this slide here is actually from the United Kingdom, where they do have a lot of offshore wind generation of power. And the size of these little diagrams basically just shows you the increase in the number of pylons and the turbines offshore for wind generation. And so this is 2001 and this is 2014. And you can see that, you know, just in the last 15 years or so, we've seen massive development in the marine environment. And this isn't just unique to the UK, we're also seeing this throughout Europe and the USA. Not so much in Australia yet, but something that might happen into the future. One of the other major types of modification of the coastal environment that I talked about was things like seawalls to protect our properties and our land from storm surge and sea level rise. And this one's actually from the USA, but it shows here, so we've got the population of humans on the y-axis here. And so this line here is the growth of the human population. And you can see that as the human population has grown, so too have the number of seawalls, because as the human population grows, we've got more and more properties and infrastructure that we need to protect. And then this photo here is actually one from the Sydney Morning Herald that was from earlier this year. And I'm not sure if you saw in the media, but we had some very big storms off the east coast of Australia that actually caused considerable damage to our coastline, both in Sydney and also on the north and south coasts of eastern Australia. And so this is one of the beaches in Sydney, Collaroy Narrabeen, and this is what happened after the storm that coincided with a high tide. So you can see people's pools washed away, you know, people's backyards eroding. And so, you know, it's this kind of event that is leading to more and more of these seawalls being built in the environment to try and prevent this kind of thing from occurring. And then, of course, being a bit futuristic, we also have these kinds of ideas as well. So what I've spoken about so far is, I guess, the types of development that we're already seeing. But you may or may not have heard about, you know, some of these kinds of plans that people have as well. So cities, whole cities that are built in our oceans. And so, you know, I guess if we're thinking into the future as well, there's all kinds of new development that might actually crop up in our coasts and our oceans. So while these types of development are really important in serving particular functions for us as humans, be it coastal protection or food production through aquaculture or supporting recreational activities, they also often have very large unintended side effects on the plants and animals that live in our coastal and marine waterways. And so these impacts might occur at a variety of stages within the life cycle of these structures. So first of all, if we're putting in a new structure, there's going to be some construction, isn't there? And so the types of activities that might occur during construction are things like this. So this is actually driving piles down into the water. So, you know, they have big bits of machinery like this. And I guess one of the things that this machinery does is that it tends to create a lot of noise. And you may know that quite a lot of marine species actually communicate, you know, via various echolocation type stuff, you know, whales and dolphins in particular. And so this kind of noise can be really disruptive to these organisms because they can't communicate with one another anymore. So it might alter their communication, or because it's really noisy, they might just choose to avoid this area. You know, if we don't like, you know, a particular environment, or if it gets really noisy, our immediate instinct is to sort of leave the area, isn't it? And so, you know, potentially we're making areas undesirable for organisms to live, so they're moving out. The other thing that can often happen, so if we're putting down all of these pillars to sort of support things like bridges, often what we're doing is stirring up the sediment that's on the seafloor or the river floor, and this is leading to turbidity plumes. So turbidity is just all of this sediment that ends up in the water. And this is a problem because actually lots of species of fish actually feed by looking for their prey items, okay? So just as, you know, we you know, can assess whether something's good food or not by looking at it, so too can fish. And if you get these big plumes, the fish aren't going to be able to see, and so they're not going to be able to actually effectively feed. So this is a problem as well. Okay, so that's the construction. So those are the types of impacts that we might see during construction. But we've also got the operation of these structures as well. And so for things like offshore wind generation, what will happen when this is under operation is that that wind turbine will actually be spinning. And so if this wind turbine is actually situated on a major migratory pathway for birds, what might happen is that, some of these birds, if they're not able to sense this turbine and actually fly around it, they might actually get hit and killed. A more local example, so if you have spent any time in the coastal zone, what we have a lot along the coastline of Australia are these swing mooring buoys. So, if people own a boat, what they can do is, moor their boat using this concrete block that is on the seafloor connected by a chain. Now, the problem is that when this is in a tidal environment, the tide rises and the tide falls. And so when the tide is high, these chains are nice and taut and there's not a problem. But when the tide goes out, the boats go down in the water column and there's a lot of slack in these chains. And what can happen if there's seagrass on the seafloor is that as the wind changes direction, this chain can move around on the bottom and it actually drags and it can kill the seagrass that is found there, which is a problem because seagrass is actually a really important habitat for things like fish that use it as a nursery ground. And so if you've ever played around in Google Earth, and this is quite a fun thing to do, if you've got a few minutes spare and you go into some of the coastal areas and you zoom in, what you can often see are these dark patches which correspond to seagrass. And in some areas where you've got lots of boats, so these white things here that you might just be able to make out, they're all boats. And what you can see is next to each boat there's a little white patch. And so what that actually is the result of this swing mooring buoy actually dragging on the seafloor and killing all the seagrass in that area. So what we're actually seeing here is just the bare sand in and amongst all the seagrass. Okay, so there's quite a lot that we can see from these aerial photos that are produced by things such as Google Earth. Okay, so that's when these structures are actually in the environment and they're operational. And then some of these structures actually have a finite lifespan. Okay, so down the bottom here you can actually see an oil platform. Okay, so this is what they were using to support oil extraction from the deep sea, and so this is what supports the pipelines and stuff. And there might become a point in time where this starts to get old, it starts to decay, it's unsafe, it presents quite a high risk, and so what they might decide to do is decommission it. And so I guess if this is stuck out in the ocean, they need to decide what to do with it, and so they might actually need to move it considerable distances by boat. And so there might be impacts associated with, towing this across the ocean for large distances. The structure of this might have all kinds of paints attached, and those paints, particularly when they start to get old, might start to flake and release things like heavy metals and contaminants into the environment, to which organisms, so plants and animals, negatively respond. Okay, so there's a whole heap of sources of impacts of these structures. And so some of these impacts can be related to loss of habitat. And so quite an interesting example to look at when we're thinking about loss of habitat is just something like a seawall. So if you've ever been to the beach in an area that is very developed, you might have noticed that, at the back of the beach there's this seawall. Okay, and so what would be the scenario on a natural beach is we sort of have this nice wide beach width, and we've got dunes, and there's all kinds of crabs that live in the dunes, and there might be turtles that come up and lay their eggs in the dune system and that kind of thing. Okay, so the first thing that happens when we build something like a seawall in this environment to protect maybe houses that are up here, or a surf club that's out up here, or whatever else, is that we actually lose beach width. So we've gone from having this much beach width to this much beach width here. Okay, so this is a problem for organisms that actually live in this high part of the beach because their habitat, the place where they live, is actually lost. The other thing that can happen through time is that if you've ever spent any amount of time on the coast, what you might notice is that beaches are very dynamic, okay? So, certain times of the year, the beach is very wide, sediment naturally accumulates on the beach, Other times of the year, the beach is naturally narrow because, you know, there might be seasons where there's naturally a lot of storm energy that erodes the beach, and then that sand will be taken offshore. It might sit in a sandbar offshore, and then over the calmer months it might gradually wash back up on shore again. And so what these structures do is actually prevent the beach from migrating back and forward and becoming wider and narrower with this seasonality in storms and that kind of thing. And so if there's a seawall here, actually the beach can't retreat, can it? And so we might entirely lose our beach during these stormy seasons. So that's not good either. And then the other thing that can happen, so sometimes we have these seawalls that are actually built low on the shore, and when they're built low on the shore, what might happen, particularly at high tide, is that the waves can actually come into contact with the wall. And so what happens is that they actually rebound. And when they rebound, it can actually lead to a lot of energy sort of eroding sediments right in front of them. And so we might actually get these seawalls actually exacerbating erosion. Okay, and so the net effects of all of these types of things are that we tend to get narrower beaches where there's seawalls. We might get changes in the beach profile, so rather than having a nice wide beach with a particular slope, we might get a narrower beach with perhaps a steeper slope. We can get differences in the grain size of the sediment, so how big the sand particles are, because I guess if we're getting a lot of erosion, the fine sediment is going to be the stuff that erodes first because it's lighter, and it's going to be the big particles of sediment that are left behind. And if we think about the types of animals that live on beaches, a lot of them actually live in the sand, things like crabs, things like worms. And because they actually live in the sand, they're really sensitive to changes in the grain size. We can get changes in the stability of the sand, so, you know, the sand being moved around and where the sand ends up as well. Okay, so I guess those are some of the impacts that we might see at a local scale, but the other thing that we need to keep in mind is that the coastal system and the marine system are all interconnected with what's going on in the land and the rivers. And so we have species of fish that naturally migrate between the rivers and the marine environment to spawn. We have things like turtles that live in the ocean and go up onto beaches to lay eggs. We have some species that move between habitat types in order to feed. Okay, and so if we start building structures in the environment, these structures might actually lead to barriers to the movement of these organisms. And so we might actually have impacts that don't just occur where these structures are built, but actually occur on larger scales. So to give you some examples, okay, so sea turtles, to lay their eggs, what they will naturally do is, I guess, haul themselves up onto land, and you can see some tracks here. They'll crawl up and they'll dig these burrows on the dune system, okay? And so you can see the eggs here of one of these sea turtles. What happens when we build a seawall along the coast is that they can't actually reach the dunes, okay, because the wall is in the way. And so what you can see here is some turtle tracks along the base of the seawall where the turtle's actually looking for where it can go up higher to lay its eggs. So the net effect can be that the turtles either aren't able to lay their eggs or they lose a lot of energy by searching for a place where they can go up higher. Okay, so this can lead to lower reproductive success in these types of organisms. Some structures don't actually stop organisms from moving, but they produce environmental conditions that deter them. And so this is actually an example from America, from the west coast, a place called Puget Sound. And they have these salmon that naturally migrate along the estuaries into marine waters. Okay, so you can see without any structures, these fish are naturally swimming along. But where we build something like a pier or a wharf, what happens is that this creates shading underneath. And these salmon actually don't like shading because I think, you know, they can't see predators and that kind of thing. And so what they'll do is actually accumulate on the upstream side of these structures and they won't actually migrate around. And so this is actually influencing their patterns of migration. And then there are other structures that actually enhance the spread of species. And so this is the underside of what something like an offshore drilling platform might look like. And you can see that attached to the structure of it is all kinds of little barnacles, bits of seaweed, all kinds of animals, okay? And so what might happen when we build these structures? So I guess if we think about the natural environment, what we might have is something like a rocky shore here, and then there might be an ocean basin with a lot of sediment, and then another rocky shore here. Okay, and we might have something like a barnacle that needs rock to attach to. Okay, and so what might be limiting to where this barnacle can actually live is how far it can move in the water. So many marine organisms have a larval stage in their life history, which means that it can float through water. And if the larval stage of this barnacle can only get that far, and this is all sediment, then it can't attach to the sediment, and so it can't survive. But what can happen is if we start building these platforms in the middle of the ocean, it might actually act as stepping stones for this barnacle to actually move from one coastline to another. And so what we can actually see is that some of these structures are helping invasive pest species to spread around the world, okay, by providing suitable habitat in environments that would otherwise be sandy and not have the right kind of surface for them to attach to, okay? And then another way in which these structures might actually influence things is by influencing predator-prey interactions. And so often when we build structures, what we see is lots and lots of fish accumulating around these, and there might be a few reasons for this. First of all, as you saw in the last photos, these structures actually often get things like invertebrates and seaweeds and, you know, barnacles and all kinds of things coming to live on them, and these can be food for the fish that the fish then feed on. But also these provide structural habitat, so places where the fish might be able to hide and, you know, seek shelter from predators and extreme events and that kind of thing. And so this is, again, is a Google Earth image, so it shows you, you know, I guess all of the exciting things you can do with Google Earth. And so here we've got these little reefs, okay, which might be made of artificial structures. Again, you've got this dark green, which is aquatic vegetation, either seagrass or seaweed. And what you can see is that around these structures, there's actually these halos where there's no seagrass or no algae. And so what happens is that these structures attract in these fish, and then these fish concentrate their feeding in these surrounding areas. And so we're actually changing the abundance of species by changing the feeding patterns of these fish. Rather than feeding everywhere, they're concentrating their feeding in these areas. And so these graphs here just sort of illustrate this. So if we look at the solid black lines, these are places where there are reefs, and you can see around the reefs, very close to reefs, so this is the distance away from these reefs, there's very high grazing, and then as we go further away it decreases. Where we don't have reefs, the grazing is more sort of distributed across the environment. So all of these things cumulatively result in changes to the structure of marine populations, their population sizes, where species live, how these species interact with one another, and some of the functions that we care about, those things like their ability to provide fisheries productivity and that kind of thing. So I guess the question is, what do we do about this? So obviously we don't want to stop development in our coasts because, you know, these developments are actually doing really important things like supporting fisheries productivity, recreation, supporting shipping, you know, all kinds of things. So how do we minimise our footprint in the marine environment? So there are three main strategies. So the first one is green engineering. And so this is a strategy that has already been used a lot on the land. So some of you might be familiar with things like green walls and green roofs. Attempts that people have made on the land to try and enhance the ecological value of our built environment. So we can also do this in the sea. So to give an example, if we think about something like a seawall has a very vertical surface, doesn't it? And it's very smooth. It doesn't have lots of microhabitats. If we think about a natural rocky shore, which might be the natural analogue of a seawall, we tend to have a predominantly vertical surface, and we've got lots of complex habitats like rock pools and crevices that lots of plants and animals like to live in. Okay, so if we're thinking in a green engineering perspective, what we might want to do is think about, well, hey, we've got a seawall that looks like this. how can we add structure to the seawall that supports these kinds of animals that live in rock pools? Because obviously there's no rock pools here. And so these are some of the approaches that have been used around Sydney. So this is a seawall down at McMahon's Point, not far from the Sydney Harbour Bridge. And what they did here when they built this seawall is actually leave these blocks in the seawall out, little cavities. And so these cavities provide a shaded and moist environment that might provide some of the similar kind of conditions to actual rock pools. And so what they found is that these cavities actually enhance biodiversity. The other thing that people have done to try and mimic the habitat that is provided by rock pools on seawalls is actually add these half flower pots. And so what happens when the tide goes out is that water gets trapped in these flower pots, and so things that need water at low tide can actually live in there. And then this is an experiment that I've been involved with recently where we've actually been adding complex habitat to flat seawalls. So you can see we've added a surface with ridges and grooves. So we're basically tiling a seawall with this habitat enhancing kind of structure. And this picture on the right here shows, I guess, what this structure does. So it can actually create lots of different microhabitats. So this is the thermal environment. The colour represents temperature. So there's hotter places and colder places. Rather than the surface all being the one temperature, we're creating temperature differential because the places in the crevices trap water, they're shaded, they're much cooler. And different types of organisms like hotter and cooler environments. And so the idea is that we can actually have organisms like hotter and cooler environments actually living side by side on these plates as opposed to the smooth surface, which might only favour animals that like hot environments. I guess one of the other things that we can do is actually think about the way that we build these structures in the first place. So rather than building a very flat surface like this, might we be able to build a seawall that looks like this? And I guess a seawall that looks like this second example is going to provide much more surface area for attachment of organisms. There's going to be lots of nooks and crannies in between for things like fish and crabs to hide in and live in, and you can see that there's even some mangroves growing up around here. Okay, so the ecological value of this second type of seawall might be much higher than the first. And then if we want to actually do an even better job, what we might consider is how we can actually build natural habitat into a seawall. So this is down in southern Sydney, and you can see that they've actually built salt marsh in the middle of the seawall, and so this salt marsh might be important habitat for particular types of species. And then to take this to the extreme, I guess in some instances people have realised that actually we might not even need a seawall at all, because actually natural vegetation, things like mangroves and salt marsh and oyster reefs, actually can help to stabilise shorelines, and they can dissipate wave energy and prevent erosion. So in other areas, if we've got lots of space and the environment is suitable for growth of these species, why do we need to build a seawall at all? Maybe we could just restore natural ecosystems, natural seagrass, mangroves and oyster reef, and this might actually serve as our natural seawall. So one of the best examples of this green engineering is actually in Seattle in the USA, and I guess this is a project underway. And so one of the things they've done here, so you might remember the salmon example I talked about before, and the salmon not liking the shaded environment. So what they've decided to do here is actually build walkways for the public along their waterfront that actually have light wells in them, so the light can actually get through to the area below, so the salmon will still migrate. So it's these simple solutions that are what is green engineering, okay? So we're not stopping development, we're just being a bit smarter about how we do it to try and minimise its impact. The second thing we can do is actually co-design, okay? So we talked about how there are lots of different uses of the marine environment. And actually, if we can, when we're building structures, use them for not just one thing, but multiple things, we might need fewer structures. Okay, so this is someone's, I guess, conceptual idea of what we might be able to do. So if we are building an offshore wind farm, maybe we can actually co-locate other activities here as well. So maybe we can have, you know, viewing platforms or hotels that are actually attached to the turbines. Maybe we can have aquaculture, mussels or something growing on the side of these. Maybe we can have areas that are artificial reefs for divers in amongst it. This one looks like it's another type of aquaculture, okay? So rather than having separate areas for aquaculture and separate areas for wind farms that, you know, might have a larger footprint, why not combine them into the one area to minimise the area that's actually affected? And then the final thing that we might be able to do is think more carefully about where we actually build these structures. Okay, so we have a fairly good idea now about where the important areas are for our marine life, okay? So we know what the migratory routes are for birds. We know, you know, I guess where there are areas of high diversity and lots of different species of fish. Okay, what we can also do is, I guess, map what areas of the marine environment are most suitable for other industries, for energy generation, for shipping, for recreation, for aquaculture. And what we might want to do is actually, if we realise that this is a really high important area here for bird migrations, what we can do is actually not build our wind farms there. If we build our wind farms somewhere else, actually that area might not be as important for bird migrations and we can minimise our impact. Okay, so I guess thinking about how spatially these different services relate and where is the best thing to do them. So overall, I guess sort of to summarise, you know, more and more what we're seeing is this development. This development is not going to stop, but what we want to make sure we do is not have development like this where these are serving as barriers for fish migrations and providing shading and disrupting species and preventing turtles from laying their eggs and, you know, causing non-native species to spread and damaging birds and that kind of thing. What we want to do is actually have development that has ecological values incorporated into it to minimise the impact. So the co-design where we've got, you know, perhaps oil drilling platforms that also support aquaculture. We might have smart spatial planning, so these wind farms built in places where we know that there's not many birds migrating, you know, and I guess structures that allow passages of organisms. So hopefully this has got you thinking a little bit more about, I guess, development in our oceans and, you know, the types of things that we can do by just being a bit more smarter about our design to try and maintain the important biodiversity of our coastal zone and the fisheries productivity and the other services that it provides. So thank you very much for your attention. We'll open it up to questions now. So start thinking about if you've got anything that you'd like to ask. So I guess erosion can be caused by a few different processes. So I guess there can be wind-driven erosion. So if we think about a beach and we've got the sand dune and then, you know, the beach going down into the water, wind can cause erosion of the sand when it blows, and that sand can be blown either on or offshore. We've also got wave action, okay? So I guess if we've got a storm event, there's a lot of energy in those waves, and that energy can actually transport that sand offshore. I guess we've got natural tidal currents that are coming and going, and so that can also move sediment away as well. And then, you know, we've also potentially got, I guess, human causes of erosion as well. So in very, very sheltered waterways, if we've got a lot of boating activity, the boats can actually cause waves, and those boats might actually lead to erosion too if the boating isn't properly managed. Hydro is talking about movement of water. So if we're talking about hydrodynamics is actually circulation patterns, so currents and waves and that kinds of things. I guess hydraulic in an engineering sense is often talking about, you know, movement of mechanical components, that kind of thing. from high school, I never really knew what I was going to do. So if you don't know where you're headed, it's not a problem, okay? Welcome to the club. And so I guess at high school I did all kinds of things. I did quite a lot of science and I did quite a lot of maths for the high school certificate. But I also did things like German and geography and English and music and a whole heap of other things as well. And I got to the end of year 12 and I thought, well, you know, I'll probably go on to university. I don't really know what I'm doing, so I'd like to do a degree that's fairly general and keeps my options open. And so the choices really were either an arts degree, which is, you know, I guess a very general degree that is more focused around the humanities, or a Bachelor of Science, which is also a very general degree that is more focused around all the different types of sciences and maths and that kind of thing. And so I actually really liked science at school, so I thought, well, I'll go and do a Bachelor of Science, but I still didn't really know what I was going to do. So in first year at university, I did a little bit of maths, a little bit of physics, a little bit of chemistry, a little biology, just basically tried out everything and, you know, saw what I liked. And I pretty quickly decided that physics wasn't really for me. I quite like chemistry, but I was a bit of a klutz and I used to spill chemicals all over myself. So I thought, well, I can't go on and become a chemist because I'll be dead by the age of 21. So biology is probably a safer option. So I kept on doing biology through university, and when I got to my third year of university, one part of the subject that I was taking was actually a field trip to the coast. And so we went to a rock platform, and basically what our lecturer did was get us to develop our own little experiments to find out, you know, I guess what the main factors were that determined where animals were living on the rocky shore. And it was terrible weather, it was the middle of winter, it was freezing cold, there was lots of rain, but for some reason I really, really liked that, and that is what made me decide to go and become a marine biologist. And so from there I did some further study. So I did something called a PhD, a Doctor of Philosophy, which is basically a 3-year project where you do your own little research project. And so I did that, and my project for that was on waves produced by boats and how they modify the coastal environment and how we can modify, how we can manage that disturbance to minimise it. And from there, yeah, I guess I got a job as a marine biologist working within universities. But, you know, there are also marine biologists working in all kinds of other places. So we've got lots of marine biologists working for the government. So both for the Department of Primary Industries, working in fisheries management and aquaculture management. We've got, I guess, marine biologists working for the Department of Environment at a national scale, or the Office of Environment and Heritage at the New South Wales scale, looking at management of our marine environments and how we can manage those for multiple purposes, and also, you know, I guess monitoring and evaluating the health of those systems and how we can maintain the health of those systems. There are also jobs with engineering firms where, you know, people going out and doing environmental impact assessments before development to see what effect development will have on the environment and what strategies we might put in place to minimise that. We've got people that work for zoos and aquaria and that kind of thing, the tourism industry with whale watching. So yeah, I mean, there are a whole heap of jobs, but yeah, that's how I got into what I do. I guess the other thing to keep in mind, so I know some of you go to schools that are a long way inland and probably haven't had a lot of connection with the coast, but if you like this kind of thing, don't let it be an impediment to you. I know lots of people that, you know, grew up inland and didn't even see the coast until, you know, they were maybe 20 or something and somehow still got into this field. So, you know, if it's something that interests you, you know, there are lots of opportunities. Thank you very much. Thank you for listening.